Okay, again, welcome. Last session of the conference. We're going to talk about GitHub. And there was a gentleman coming up just before our talk to ask us if we were also going to touch upon Azure DevOps. Yes, we are. So if you're a DevOps shop and you're interested in the features that are on offer, we're also going to talk about that a lot. So,
or a bit.
Or a bit. Or, yeah, we'll see.
Something in
no problem.
Between.
Yeah. Okay, so in the next 60 minutes, we're going to entertain or inform you about the possibilities that the GitHub platform offers you to make your code better, more secure, primarily more secure, maybe also better. GitHub offers quite a few capabilities for that out of the box. Some of them are hidden behind, I wanted to say a paywall, but it's not really a paywall, behind a subscription. And then we're also going to talk about Azure DevOps. But before we start, a little bit about ourselves. I'm Thomas Vochten, I'm from Belgium. I am a technology evangelist, Microsoft MVP. That both means that I like talking about technology a lot. That's what I do. Usually behind PowerPoint decks. That's where I spend my time. I must say, this is my, I guess, 5th or 6th time in Norway. I have only been in Oslo yet, so I haven't yet discovered the rest of this beautiful country. But so where I come from in Belgium, we speak Dutch, like in the Netherlands. And it always struck me that when I walk around here, I can read, well, not everything, but most of the signs. A lot of the words are actually really, really similar. Apart from when you guys start to speak, then I'm like, flatline, it's okay. It's a little bit different, but reading is quite okay. So, and something else, I think I was lucky to arrive only on Tuesday, because I remember, or I heard that in the weekend, the temperature was a bit lower than now. And in Belgium, we have the same temperature right now, more or less, and it's a big drama, because it's the first time in 3 or 4 years that the temperature drops below 0 during daytime. So people are everything stops moving, and it's not even snowing. So okay, but enough about me. I'm joined by my esteemed colleague Laura.
My name is Laura Kokkarinen. I'm from Finland, and I don't talk as much as Thomas. Sorry, that was quite a long intro. I was like.
Yeah, no worries.
Anyway, I'm a software architect and a developer at a consulting company called Sulava. I'm also a Microsoft MVP in the Azure and Microsoft 365 development categories. Write a blog at laurakokkarinen.com, and if you would like to follow me on social media, that's my handle, and that's Thomas's handle as well over there. So, during these approximately, how many minutes do we have left?
57 minutes, sorry.
We will go through the following topics. So first, I will very quickly touch upon what kind of threats our web applications face today, and how something called secure software development lifecycle can help us counter those threats. Then we will dive deep into what kind of code security checks we can automate as a part of that lifecycle. We will take a look at Defender for cloud integration, and then how is Azure DevOps faring these days compared to GitHub? What kind of features do we have there? Have we something less? Have we something more? What is the future looking like when we have GitHub, GitHub Enterprise, and Azure DevOps all owned by Microsoft? All right. So OWASP Top 10 is probably very familiar to many of you, but as not everyone necessarily are aware of what this is, I'm just going to briefly recap it. So OWASP Top 10 is this awareness document of the most critical security risks our web applications face today. It is developed by the Open Web Application Security Project Foundation, and it is one of their flagship projects. Basically, every few years they do this field research where they investigate which threats are the most important or most prevalent for our web applications today, and then put together this kind of a list. This is from 2021, and the previous iteration was from 2017. So the broken access control category is all about user permissions. Users should not have access to any information that is intended for them, so they should not be able to get more privileges for themselves or access documents, like if there's access controls missing. And also if we don't follow something called principle of least privilege, so giving users as little permissions as possible, that's also an issue in this category. Cryptographic failures are about encrypting data in the database and while it's being transferred between systems. And other kinds of issues in this category are if we are, for example, using encoding or hashing algorithms instead of encryption algorithms, or if we are not securely handling the encryption keys. Then injection is about attacker being able to input some kind of code or script to a web application, and if our web app does not sanitize the input, meaning stripping the script element from that input on the server side and executes that, it ends up executing the code and behaving in an unintended manner, which could be really drastic for the web app. Then insecure design is about fundamental design issues that allow regular features of the web app to be misused for something bad. So it's not really an implementation issue or configuration issue, but something like that has not been thought to be able to be misused. Then security misconfiguration is quite self-explanatory, so it's a configuration value that is not secure enough and that causes a security vulnerability. It could also be like features are enabled which increase the attack surface and that way potentially allow the attacker to come into the system even though we are not really needing the feature that's like the entry port to the system. Then vulnerable and outdated components are about dependencies that contain vulnerabilities or are just outdated. So today when we build web applications, we are using a lot of packages and we should also make regularly sure that those are updated and patched if they are found to be vulnerable. Identification and authentication failures are about a user being able to pose as another user and that way gaining access to more information than they are meant to have access to. That could happen, for example, if they steal the session ID or access token or are able to brute force themselves into the system. Then software and data integrity failures are about us not verifying that the logic or data that we are accepting to be a part of our application is coming from a trusted source and that it has not been tampered with before it reaches our web application. And that typically happens by checking some kind of signature or a checksum or hash. Then security logging and monitoring failures are about us not logging important data on a sufficient enough level or logging sensitive information or not backing up our logs or if we are able to modify the logs which should be immutable. Those are all examples of vulnerabilities in this category. And server-side request forgery is about an attack that user supplies an internal resource URL that is not normally accessible over the public internet, but because the server side is behind a firewall, it is able to fetch the protected content from there and then pop it out on the client side. All right, so now we vaguely are aware of what kind of threats our web applications face today, and now we can talk about something called secure software development lifecycle. That is a really good and cost-efficient way to protect our web applications against these threats. So you might probably first think that, okay, if we just pen test our applications, that's all good, but it's not actually sufficient, nor necessarily the most cost-efficient way of doing security for web apps. And the secure software development lifecycle is this framework or process where we prioritize security at every single stage of the lifecycle. So as early as possible, we check for security issues and fix them as early as possible when it is the cheapest. So just like with regular software development, when a bug is discovered at a late phase of the lifecycle, that's when it's the most expensive to fix compared to if it was immediately discovered and fixed early on. So the first phase actually begins even before a software development project starts. So all the project team members should go through security training depending on their role. So software developers should be trained on application security, product owners should be aware of security from their point of view, and so on. So everyone knows what is their responsibility when it comes to the application security. Then defining requirements is about taking into account what is the functionality of our application, what is the current threat landscape, and then considering what kind of threats our web app could face. Designing is about taking those requirements and creating a secure software architecture. And when we have that plan created, then we can go to implementation, where we implement the software according to that plan while simultaneously adhering to secure coding practices. Then we of course test the implementation, and here we can use a lot of automation, so we have code scanning, and we can even have like automated tools that help us pen test the changes. And of course, when we have tested that our implementation does not contain vulnerabilities, then we can deploy it to an environment, ideally through a CI/CD pipeline. And when we have the solution in prod, then there's the maintenance phase. And here we should continue ensuring that those dependencies are updated and free of vulnerabilities, and that we also have a good incident response process in place in case a breach happens, so we know immediately what to do. And this process does not always look exactly the same, but it usually has those 7 steps available. And here's one example. So Microsoft has this Microsoft Security Development Lifecycle, and as we can see, they have like 12 different steps, but they all fall into these 7 categories, except for deployment. I don't know why they have not included deployment through CI/CD pipelines in this, but maybe they don't consider that to be like a minimum requirement. But yeah, this is one way of how you can implement the secure software development lifecycle, and it always varies a little bit depending on the organization and their ways of working. And why is following the secure software development lifecycle important? Well, as I briefly already touched upon the fact that it saves us money. So even though you initially need to invest time and money and effort into learning these new ways of working, in the long run it pays itself off because we have less vulnerabilities at the end, and security breaches can be extremely expensive, and fixing issues at the end can be extremely expensive. So yeah, we have a reduced number of security vulnerabilities in our app, and because we do so much thorough testing, we usually end up also improving the general quality of the application. It's also easy to include adhering to regulations and standards during this process, and when we make such high quality software, our customers tend to be satisfied with us, and they trust in us that okay, we do high quality software, we don't necessarily need to be as afraid of data breaches, and they are happy and they tell their friends, and in the end we end up getting this kind of reputation that we do really good software, and other people want to also get software from us. So that's like a competitive advantage towards compared to other companies who don't necessarily follow this process. And yeah, this also gives us reduced development costs because we fix the issues really early on. When is it feasible to implement? Microsoft gives these 3 criteria. So if your web application deals with business, enterprise, or infrastructure environment, contains sensitive information, or communicates over a network. So you can probably already guess at that 3rd point that communicates over a network, always implement this. And ideally, you should take this into use early on in the project, because then you get the most bang for your buck, so to speak. But it's never too late. So even if you are already in the maintenance phase, you should take this into use, because you still need to probably implement new features, fix bugs, update those dependencies, and so on. So which steps can be automated during this lifecycle? We could automate some steps of threat modeling. So we have tools where you can, for example, draw the architecture diagram, and then it suggests that you should check these things that they're correctly configured. Then we have automated code analysis that we'll be talking about a lot during this session. Security testing, configuration scanning can be automated. For example, if you have set up resources on Azure, we have tools for scanning those configurations, like are those values correct. Then we have automated CI/CD pipelines that take our code, build it, and deploy it. And incident response processes can also be partly automated. So for example, if we are using a CM product like Azure Sentinel, for example, we can make it to read our application logs, surface an incident if it notices something suspicious, and from that we can even create further automations to take some actions based on that incident. But how can GitHub help us automating some of those tasks during the secure software development lifecycle?
Exactly. Let's switch some gears a little bit and look at the the features that GitHub offers us to enable or to implement a secure software development lifecycle. Basically, it boils down to these three capabilities, or three categories if you want. We want to scan for secrets to make sure that nothing sensitive makes it into our repository. We want to look at the code itself to see if we're not doing something fishy from a security standpoint, to see if we're not doing anything well, let's say, not so clever, not necessarily related to security, but might be something else, and like another coding problem. And we also want to have a look at our dependencies, because everybody uses dependencies. No matter how small the project, dependencies are always there, even if you stay inside the framework that you are building software for. So those are the three main capabilities that GitHub offers us. The cool thing about these capabilities is that it's free, at least for public repositories. So if you're working on an open source project or something that you are putting out there to the public, if it's a public repository, you will get these capabilities out of the box. That's the good side of the story. If you're working on a private repository, which probably is also the case, you will need to pay for these capabilities, and it's called GitHub Advanced Security. So it's free if you're using a public repo, but if you're using a private repo and you want to use these capabilities, you will have to pay. So you will have to have a paying subscription, and then you can have GitHub Advanced Security. That is true for almost everything that we're going to discuss today. There are two exceptions that I will get to, which also need some extra money to be paid to make that available. But if you're using something for yourself, it's public, you can use these capabilities at will. So the first one we're going to look at is secret scanning. As the name implies, what does it do? It's fairly, well, self-evident, I would say. It prevents you from exposing stuff that should not be exposed in the public or in your private repo even. So everything related to passwords or tokens or private keys, any other secret that you do not want to end up in your repository can be detected by secret scanning, by that capability. The cool thing is it doesn't just look at the current, I know it's not a Git terminology, but at the current version of the code, it will also be able to scan your Git history, for example. So even if you haven't activated this capability now, and you activate it now, but you committed a secret 2 months ago, 2 years ago, this capability will still be able to find that secret and alert you that it's there. So it will scan across all the branches also, not just the main or the master branch, everything and all the different and all the Git history will be also checked. The way it works, it works through pattern matching. I'm coming back to that in the next slide. But it also doesn't scan the code itself, not just the code. It also will look at descriptions in pull requests, it will look at issues, it will look at most of the assets that live around your code to see if you've exposed something that should not be exposed. Then it gives you an alert, and that is true for all the capabilities that we're going to talk about today. There is different tabs in your repository that will give an alert, a list of alerts of the things you should look at, but that is fairly simple to discover. So in a nutshell, that's what secret scanning is all about. This is an example of some of the secret scanning patterns. These are examples from Azure, but there are many more. I don't know, it's more than 100 last time I checked. Different kind of patterns from different vendors. So these are Microsoft secrets. There's also like AWS and Google, and you name it. A lot of different integrations are possible. The way it works is it works through regex. So that's how they are identified. Now you have to be careful because these patterns, they change over time. So for example, an Azure function key, which is on this slide, has a certain manifestation, but maybe 5 years ago that manifestation or that definition was maybe a little bit different. So you always have to be a bit careful, because if you have a newer secret, it will automatically be detected, but if it's a very old secret with a completely other structure, there's a fair chance that it's not detected. So you always have to be a little bit careful, read the documentation to see from which version of those secrets secret scanning will work. So it comes with a little disclaimer, I would say. So never fully rely on this, but this is a tool that might help you to identify these secrets. So always have to be a little bit careful. So there are many more than what is pictured on this slide. It gets even cooler, because Microsoft has this partner program. So GitHub belongs to Microsoft, I'm sure you're aware. So they have a partner program where the vendors of these secrets, I would say, they can tie in to this secret scanning mechanism and make sure that if a secret is detected, that secret automatically gets revoked and on the source. So if you put an Azure storage key, for example, in your code and it gets detected, you get an alert, but Microsoft will also be able to automatically revoke that secret for you. It's maybe not always what you want, but I think in this case, especially for a public repo, it's not a bad idea. I'm not sure, but I don't think that every vendor implements this. Depends a little bit, but that's the general idea. So the other partners, there is a way to integrate the secrets that you have into this partner program. By the way, if you're an ISV or you have your own secrets and which have a specific structure, you can also talk to Microsoft. There's a few things to fill in. There is a manifest, of course, that you need to provide on how your secrets look like, and then you can also integrate your own secrets into this system if you're a vendor yourself. So it runs automatically, the secret scanning, on all the public repositories. So, and if it's on a public repository, it will automatically be revoked at the vendor itself. So they have to provide an API to Microsoft to make that possible. So that is part of the specification if you want to be included into this partner program. So configuration is, and that is true for almost everything that I'm going to talk about, configuration is fairly simple. Basically, usually is just checking a few checkboxes in the GitHub interface. It comes in quite handy. So in this case, you can enable or disable secret scanning for a repository, for your organization, for your account even for your user account. So that's just a checkbox, and then you enable it for one or more repositories. Of course, there might always be a case where you deliberately want some certain secrets to end up in the code, for example, for demonstration purposes, or I don't know which other reason. That is possible. You can create a YAML file, put that in a specific location, and then you can tell the engine to ignore certain stuff. Okay, don't look at this file. I know it will contain a secret, or there is a false positive, or whatever. This is all configurable. So if you want, you can create the secret scanning YAML file to make sure it is, it might be detected, but not alerted or revoked. That is mainly the only configuration you can do. When a secret is detected, you get an alert. So all kinds of people are alerted. The contributor of the code itself will be alerted, the repository administrators, and the organization owners. There is a security tab in your repo. It's right there, and it will list the potential secrets that are detected in your code. And if you go to such an alert, it looks a little bit like this. Well, you can take photos of this. This is already revoked, so I don't care. In this case, I have an Azure storage account key in my code that is being detected. It gives you a little bit information, depending on the vendor. That information is coming from the vendor. And you can do several things. You can remove it from the code, or you can say, well, okay, I know it's there. I don't really care. I'm using it for testing. It's a false positive, or I know it's there, but I don't want to fix it. So there's always a possibility to do that, but only administrators of the repo can do that. So it depends a little bit on your role. It also gives you information on where exactly in the code the secret can be found. So that is what it does. what they announced recently and what they already have implemented for GitHub secrets themselves, so like personal access tokens, and in the future also for other secrets, it will give you more information on the validity of the token. When does it expire? When was it created? Who created it? Etc. etc. That information will also come in the future in the, I don't know, next weeks or months. If it's a GitHub secret, and maybe I should have put a GitHub secret here, then you get that information already out of the box. So let's say we've got a secret detected in our code. What should we do now? Because it's in the repository. There is something you should do. You should remove it. Revoking it might be the only option. It might be the first action that you do, but it's probably a good idea to actually remove it from the source code in the repository. There is a default way using Git. There is an article on the Git support website that tells you exactly how to remove something from history. And if you've been working with Git and no one is really a Git guru, it takes quite a few steps. It can be quite complicated, especially if you've got multiple secrets in multiple branches in a lot of files in your history. There is also an open source tool called BFG that makes that work a lot simpler actually. And that's what I've used in the past. It's also in the GitHub documentation. So this is probably the way to go. These are two examples of how you can remove that data from your Git history. You can remove the file themselves if you want, or you can give it a text file where it can look for certain patterns, and that pattern, that password, that secret will be removed and replaced by something else in the Git history. So if you've done that, you know you're safe, and then you push that all up, and then you should be okay. So that is all cool, but it would be even cooler if we could prevent and having secrets ending up in our code in the first place. So that's why we also have push protection, which is also something you can enable. This is a screenshot from my PC. So I've got a piece of code, and I put, deliberately of course, an Azure function key in there. And the moment I want to push this to GitHub, it won't let me. It's also something you can enable. And it will tell me, you cannot push this code because we have an alert for GitHub push protection. It will tell you what kind of alert it is. In this case, an Azure function key. It will tell you in which code file it is and which commit it is. There's two things you can do now, or you can remove that from your commits. If it's the last commit, you can just amend the last commit and make sure it goes away. If you're pushing multiple commits at the same time, there are a few commands that you need to run, and rebasing and everything, to make sure these secrets are removed from your commit before you push everything up to GitHub. But that is also, again, very well documented if you're in that situation. Another thing you might want to do, if you know that you're committing a secret and you want it to end up in GitHub, nevertheless you have push protection, there is a URL that is provided, no, not this one, a URL that is provided where you can go to, and then you can say, okay, I know I'm committing a secret, I know why, this is the reason, and please let me do it. And when you click that URL is valid for, 90 minutes or something. When you go to that URL, you log in, and then you can still push that if you want to. So push protection override is also available. You end up at this nice screen, and you've got the same reasons as we saw before. So you can specify that it's just for testing, or that you don't care, or something else, or that it's a false positive. But of course, we want to log something like this. So what it does, it automatically creates an issue. It will automatically close that issue, but it will still be logged in the issue list. So if you go to the closed issues, you see something like the right-hand side of the screen. So you can always see who pushed the secret, and also who closed this, and which reasons. And so you can always find the one who is guilty of pushing a secret and trying to override the push protection. Again, this is configurable. You can play a little bit with permissions to make it a little bit more fine-grained, but that's basically the idea. So this is the ideal situation, especially if you're starting out with a new repository. Push protection is a really nice way to provide all this miserable stuff with secrets in your code in the first place. You also get an email, or the administrator will always get an email like, okay, someone bypassed push protection, because that's something you want to know. So that was the default functionality of secret scanning. Now we are, let's see, 23 slides in, and now we're only talking about AI, so that's good. This a new feature that has been announced only for paying customers, unfortunately, for GitHub Enterprise customers, and it's called generic secret detection. Because if you start playing with secret scanning and you say, I'm clever, I'm going to test this, I don't know, in my code I create a variable called password, it's just clear text, I put something in, that will not be detected by the default secret scanning because it doesn't match one of these patterns from the vendors, because it might be something else that is secret or should be secret, but the engine will not recognize it. With the power of the LLMs these days, of course, that's a little bit easier. So what you can do here, you can activate this engine and it will try to, with an LLM, with AI, try to identify other secrets that are not detected by the patterns in your code. It's basically the same thing if you've got GitHub Copilot, for example, or Copilot Chat in Visual Studio Code. If you highlight a piece of code and you ask the engine, does it contain a password? And it says yes, it's more or less the same as this, right? So it will look at the whole code and try to deduct if there is a password or another secret present. In this case, it's a MongoDB password. So it is available for paying customers only. Who knows if it might ever be available for free? We'll see about that. So that was secret scanning. Second capability, code scanning. So now we're going to look at the code itself, not just the secrets, but the way you configured or you developed your application. Primarily, or in this case, or in our talk, we are primarily interested in security vulnerabilities, but these tools can also look at the structure of your code, what kind of patterns you are using, if there are any potential problems there. So it will identify much more than what we are touching upon in this case. So the code scanning will typically run on a schedule. If you're using the default configuration, it will scan, I don't know, once a week or something. And on certain events, typically push events, or if you're creating a pull request, then it will scan your code. It will also create an alert, like with secret scanning, and everything is based on GitHub Actions, which means that you can also interface with it and also change the behavior of the system if you want that. That's a cool thing. So you can always integrate it with another CI/CD engine that you have. Everything is possible because we're using the GitHub action here. So code scanning works also through providers. There is something provided to you by GitHub. It's called CodeQL. We'll get back to that in the next slides. Or you can use a third-party tool. In our testing, we use TonerCloud, but there are many, many other tools available for you. As long as they support this industry standard static analysis results interchange format file, well, quite a mouthful, it will be supported and it will be able to be integrated into the code scanning. This is just a screenshot with a few examples. There are many more standard integrations possible. So that is, if you're using another engine, there's a fair chance that it might already be in this list. Or you can go the GitHub way, or the default way, I would say, and that's called a CodeQL. Now, we could do a whole day about CodeQL, so I'm just touching on the basics here of CodeQL. What CodeQL does, basically, it looks at your code and it creates a database about that code. So a database that contains everything in your code, so you can ask it questions. How many variables with that name do I have? How many patterns of this and that can I find in your code? That is what CodeQL provides, and therefore it also enables us to ask questions about security problems or potential security problems in your code. So it's essentially a database. It's quite powerful. You can also integrate it with Visual Studio Code if you want, and create your database yourself and ask it all kinds of questions, not even related to security, but in this case we're interested in the security capabilities. So that engine is something you can manipulate yourself. It's open source. It supports many languages. I think that's the next slide, yeah. It supports many languages. Most of the languages, most of the common languages are supported. It is open source, so you can go and look at the CodeQL repo itself to see, okay, what kind of things in the language that I'm using is possible. What kind of queries can I do? There's a whole community around CodeQL if you're interested to learn more. So that is, but the most common things are there: JavaScript, TypeScript, C#, Go, Java. Ruby, Python, well, you can read the slide, is a screenshot from the documentation. So the most things in the most recent versions with the most common frameworks are probably supported for you. So that's CodeQL. To use CodeQL to do code scanning, you can do a number of things. Again, it's GitHub, so you go to the settings page and you click a few boxes, and you say, okay, I want to use CodeQL for my code scanning. There's various configuration options. There's a default configuration options which Microsoft wants you to use, and there's an advanced configuration if you want to do something funky or something special or very specific that is necessary in your code. Both of these ways, both the default and the advanced configuration, they use GitHub Actions, well, this GitHub action in particular. So normally it will automatically detect the language you're using. In this case, in the screenshot, it's C#, and then you're able to configure a few detection mechanisms. There is a default one that also includes security, and then more basic ones, more advanced ones, but if you go for the default, the security is also covered. By default, it will scan the main branch, but you also can run it on different branches if you want, or just on check-in, just on check-in doesn't exist in Git, or just with a pull request, etc. So that's very powerful, but again, it's a little bit more than what we are talking about today. The alerts that are generated by code scanning, no matter if they are generated by CodeQL or a third-party tool that you're using, they will again all end up here. So in this case, we have a critical alert for Azure storage account keys that should not be disclosed. That's what we did before. But it will also detect other problems with your code. For example, the second one, constant condition. I don't know what I tried to do there, but it's detected by CodeQL that I'm doing something funky there. You have to look at it. It's also not critical. It's a warning. And I also have a useless assignment to a local variable. Again, nothing that is necessarily related to security, but to the code quality itself. And as you see, you can integrate both at the same time. So you can use CodeQL and another third-party engine if you want. So you don't have to choose. You can use both if you want, if that provides you with more information. The alerts more or less look the same. So in this case, this is a screenshot from the documentation. We've got uncontrolled data used in a path expression. So that is something we do not want, because the input that we get is unreliable, and we might end up with a security problem here. So it will, again, tell you where the problem is, what you can do with it, and if necessary, also some links to public vulnerabilities that you might want to read up on, and that will also describe what you can do to make sure it doesn't happen anymore. So that is the code. That's the alert itself. What is also nice is that it also integrates with pull requests. In this case, the screenshot is a pull request. And we configured it that Sonar Cloud, so one of these third-party tools, will first scan the code for code quality before you can actually work with the pull request, before you can merge it or do anything else with it. In Sonar Cloud, in this case, we defined a quality gate in which we specified we don't want to allow any security vulnerabilities. We don't care about the rest. And then Sonar Cloud will integrate with the pull request and say, okay, we scanned the code, we found a security hotspot, you should look at it, and it will refuse you to integrate or to accept the pull request. So there is quite a few configuration options here if you want, but that's the basic idea. So if you resolve this, then you can, and everything is green, then it will allow you to merge the pull request into your repository. There is also if you're using CodeQL at least, there is also CodeQL CLI. So if you're not using GitHub Actions and you want to use something else as a CI system, you can also integrate it like that and feed that information back to the pull request. So you don't necessarily have to use GitHub Actions for this scanning if you're using CodeQL for this to work. Again, code scanning, free for public repositories, not free for private repositories. And also here, there is an AI edition, which is also not free. Autofix, I haven't seen it in action yet because it has been announced, but I haven't seen it myself. So we'll see. So what this will do is it will automatically suggest fixes for your code. So if you did something not too clever, or something that is a security problem, or might be a security problem, AutoFix will suggest you how to change the code. It just works for JavaScript and TypeScript right now. They have plans to make it work for other languages too. Again, it's only for GitHub Enterprise customers.
And if you click on commit fix, that will automatically fix it for you. You don't need to go and change the code yourself?
Yes.
Okay, that's nice.
But of course, I think it's wise to have a good look at it. Now, there is a little bit more to it than what is on this slide. So that means that before it suggests you things, it does tests in the background. Mm-hmm. So it will already try to make sure that everything is still consistent. I believe it even does some kind of compilation or other analysis to make sure it works. But yeah, it's AI. It's again just based on a large language model. So I would suggest you to really pay attention. They're building all kinds of checks to make sure that the suggestions, it's not just the naked suggestion that is coming from the large language model. They're integrating in the backend tests to make sure that it's sensible but again, this is also a machine, so you're never sure. That is something you have to, I still have to test it, but it's possible. So we'll see what happens. But again, this is maybe more or less the same again as selecting code in Visual Studio Code and then going to GitHub chat and asking, make this better or something. But it's a little bit better than this. But it is available again, sadly, only for paying GitHub Enterprise customers. All right. So we talked about the code quality. That code quality also looks at a database, which is called the GitHub Advisory Database. Information in that database is sourced from many other vulnerability databases on the internet. So they gather that information from a little bit of everywhere. And that is the basis for all these code canning activities. So if you've got an alert, it will refer to one of the advisories in the database. So again, every advisory gives a lot of information on, gives examples on what the problem is, how to work around it, how to fix it, etc., etc., for which libraries it is relevant, and the list goes on, and some more information if you want to dive deep into a problem. Because especially with the AutoFix, or the AutoFix makes it maybe a little bit more easy, but not every developer is a security expert. So if you present it with a problem, okay, this code has a problem, do something about it, well, okay, you're on your own. What do I have to do? This can already help you. And if you're paying customer and you use AutoFix, it might also help you a little bit more. But because not everyone, if you're presented with a problem, then not everyone knows what to do. So that's the code scanning itself. Let's go to dependencies, the third functionality. Again, like I said in the beginning, everyone uses dependencies, usually a lot, and usually a lot more than you realize. Microsoft has a dependency, or GitHub has a dependency graph, where you can have a nice list of all the dependencies that are detected in your code. You can use this just for reference. You can also export this as a software bill of materials. You can do all kinds of things with it. That is what they made available right now. There is also a dependency review that will come to make sure that when a developer checks in code that will require a newer version of a certain dependency, that you also get an alert, etc., etc. So that's what the dependency graph gives you. But we are here about the Dependabot, to talk about the Dependabot. If you've got code in GitHub and you've got the repo, then you've already probably received an email on for me it's every Wednesday, I don't know, it's the same for everyone. Every Wednesday I get an email that says, okay, you've got dependencies that you need to upgrade. So it will look at your code, look at all the dependencies, and look at the ones that might be vulnerable, because if you don't realize that, you are alerted. So let's look at those capabilities. So that is the email. In this case, I'm using a SQL client library that is not up to date anymore. It contains security vulnerabilities, and it will tell me, okay, you need to update to this and that. Those alerts will also appear in the in the alerts in your repo, and then again, like the secret scanning and the code scanning, you will get an alert and it will say, okay, in this library we've got a .NET information disclosure vulnerability, for example, in this case. So you're able to read up on it, and you might want to upgrade your dependency version after you tested it, of course. Dependabot is also capable of doing pull requests by itself. So if you've got a dependency that is out of date or has a security problem, Dependabot will create a pull request or can be configured to create a pull request. So you just have to review it and then accept. Maybe not in the real world, but at least it gives you a suggestion on what to change. It can also group multiple version upgrades in the same pull request these days. So it's they changed the feature a little bit. So that makes it also quite handy. Some other options. There's also a configuration file here, the Dependabot YAML file. There is also a few rules that you can configure, for example, for test environments, that is there by default, but also to make sure that some things are auto-triaged if you've got any problems. You can also override certain behaviors if you want through the Dependabot YAML file. So those were the dependencies. So we looked at secret scanning, we looked at code scanning, we looked at dependency scanning. Those are the features that GitHub provides you. Now we're going to look at two other things, very short, about Defender for Cloud, which is an Azure security feature, I would say. And then we're going to talk about Azure DevOps. So Defender for Cloud integration integrates with secret scanning, code scanning, and everything we saw. It works both ways. So if you've got certain, I would say, governance rules around your code repositories, for example, we want secret scanning to be enabled on every repo, Defender for Cloud can tell you that. Or we have vulnerabilities in our code that are detected and that we're not doing anything about. Also, Defender for Cloud can detect that and also warn you about this. This is how that looks like. It's more or less the same information as in GitHub, but then in Defender for Cloud. All right, I talked a lot. Time to maybe too much. Now let's look at the same capabilities in Azure DevOps.
Let's pick up the pace. So do we have similar features on Azure DevOps? Is there something missing, or is there something more than what Thomas just showed you on the GitHub side? I'm happy that today we have GitHub Advanced Security for Azure DevOps as well. This became GA just in September last year. And before that, it became into preview on May the same year. So the preview period was very short, and now it's GA, and that's great. So it also includes the secret, code, and dependency scanning that Thomas just talked about, and it's really easy to enable. And you enable it for each repository separately, and I think that is a good thing because the licensing is quite expensive, and we will talk about it later. So you need to be a project collection administrator, which are quite high privileges in the DevOps organization. And when you go to the project settings and select the repository, then you have this at the very top, this toggle, and then you can enable it, and you have this GitHub Advanced Security for Azure DevOps for that repository. And when you enable it, it immediately starts scanning the repo for secrets. And simultaneously, it by default enables the push protection, so new secrets cannot be pushed into the repo anymore. And when the scan has been completed, it shows if there are any secrets that are found under Repos, Advanced Security, and the Secrets tab. As you can see, there's also Code Scanning and Dependencies tab. And then you can open this alert to see more information about it. You can see the file, where the secret is located, and what is the recommended action to take. And usually that means that ASAP, you should revoke that secret, so in case it's already leaked, it cannot be used. And then you can mark it as revoked, that okay, it's taken care of, we are no longer vulnerable. And of course then you have created a new secret and have not put it into the repo. Or if it's like a local development environment, you can select like risk accepted, or if it's not actually a secret, then you can mark it as a false positive. And this is what the push protection looks like on the browser. It also works when you're pushing from the command line on Visual Studio. Then code scanning, we now also have CodeQL on Azure DevOps side. It uses the same analysis engine as GitHub and supports these languages. I think they're pretty much the same as on the GitHub side. And these queries are open source, so in case you feel like something should be changed, you can always go and make a pull request for that repo. This is not quite as easy and straightforward to use as on GitHub, so you actually need to go and make a change to the CI/CD pipeline. So you need to add those 4 tasks to your pipeline, and only after that this starts to work for your repo. But still, it's relatively easy to set up because you don't need to go to any third-party website and get a subscription and so on. And based on my experience, I compared this one with the Sonar Cloud, and Sonar Cloud was able to find more issues, especially quality issues. But considering that you need to go to the Sonar Cloud website and set up a subscription, yada, 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 you really need to make the choice, like, do you want to take the easy to take into use approach or the get more quality issue results approach. And this is what it looks like, similar to the secret scanning. So you get a description of the issue, the recommendation, and then you can either accept the risk or mark it as a false positive, or actually fix the issue, which would be like the recommended thing, in which case this automatically disappears the next time the CI/CD pipeline is run. And after a while, you probably have quite a lot of these alerts. And in this view, this is from the Dependencies tab, but it looks exactly the same on the Code Scanning tab. We have that drop-down where you can filter these different kinds of alerts and see like what was the reason for closing it. Then about dependencies, well, it checks the packages that you have installed for your projects. It checks the direct dependencies, so the package that is directly installed to your project, but also the dependencies of a dependencies of a dependencies. And it's based on the GitHub advisory database. And again, you need to add a task to your build pipeline, so not quite as easy as on GitHub side. And from my experience, this seems to find more vulnerabilities than the third-party tools that I have been using, but it doesn't display the inheritance path. So it only shows like, okay, the vulnerability is in this package, but it doesn't tell like through which dependency is it coming from into my project. So that's like, okay, if I'm getting that dependency from several places, then which one of these direct dependencies I can expect a patch from. It doesn't send any email alerts when new issues are found, like some competitors, and it doesn't allow me to like break the build if issues are found. Okay, now pricing things, which are always fun when it comes to Microsoft.
We will distribute the slides, so if you're for these kind of details, we can maybe we can also people can see that on the slides also. So if we can, if you wanted to skip them, if you
this is really important.
Okay, sorry. I thought that was the intention.
No, this is like the most important thing of this topic, because it costs 50 euros per month per active committer, and an active committer means that any person who commits even a single line of code into any of the repositories where this feature is enabled triggers that, and it gets built through your Azure subscription. So that's why you should be really careful for which repositories you enable this, because for example in our company we have a repository for PowerShell scripts that our consultants use, and maybe they once in a blue moon go and do some little change in there, and we don't want to trigger this kind of a licensing thing for that. But like for other projects where we really need to have this kind of scanning going, then it's worth the money. And yeah, this is built through the Azure subscription. And if you have multiple DevOps organizations connected to the same Azure subscription, you only need one license per user. I'll briefly tell about other options that we used to use. These are not really that important, but as we still have 7 minutes, I might as well. So, in the past, the Microsoft Defender for Cloud for DevOps used to contain secret scanning, but after it came out of preview just by the end of last year, they no longer include that. Instead, they recommend go and enable the GitHub Advanced Security for Azure DevOps. That's probably they remove that feature so they can like make people buy that product instead. But this is still useful for one thing. So there's infrastructure as code scanning that isn't available for GitHub Advanced Security for Azure DevOps. So it's still nice to enable that feature, and then you need to install an extension for your Azure DevOps organization, add that task to your build pipeline, and then you get information about potential configuration issues in your ARM or Bicep templates. And this is what it looks like if it's if you have the pull request annotations enabled and you make a pull request and it finds an issue, then it shows you that in the comments. And if you combine this with a branch policy that requires you to resolve comments before you're able to merge your feature branch to your develop branch, if you're using the Git flow strategy, then this is what it looks like. Okay, code scanning, another option if you think the GitHub Advanced Security for Azure DevOps is too expensive. Sonar Cloud starts with just $10 per month. It contained 100,000 lines of code to be scanned for that price, so it's quite nice, and it's good. I highly recommend. But yeah, that also requires that kind of build pipeline configuration over there. And this is what it looks like, again, in a pull request view. So ideally, you always do code scanning when you're making a pull request before the code ends up in the branch where all the feature branches are merged. And here it complains that I have that kind of a syntax thingy there. It wasn't actually an issue, so I just used this Dropbox to say that I won't fix this. But it could have also been something else, and then when I fix it, it clears this comment away from the pull request view, and then I'm able to merge it. Dependency scanning, I've used a product called Snook and been very happy with it. It sends email alerts when new vulnerabilities are found and also allows me to break the build when there is an issue, so it doesn't allow me to push the product further before I take care of it. There's a sponsor at this event called Mend.io that also has a product for this. But I tested and it wasn't that good in my opinion. Don't tell them. Okay. This is really good at reporting the direct and transitive dependencies, so it gives you a direct path through which dependencies the vulnerable package is coming from, so you know that, it's coming from down there. And then you can fix it, you can override it. So, okay, this slint package has not been patched, but if I go and override this vulnerable acorn package, then I just, get a later version of that, but otherwise use the slint as it is. That's one way of doing it. And this is the syntax for if you're using NuGet packages. Both of these are found from Microsoft documentation, so if you need to do this kind of override, you can go and check the syntax from there. So, which way to go? Use GitHub Advanced Security for Azure DevOps or some of those third-party tools. Ideally, you would of course use both, because different tools find different vulnerabilities, and the more tools you use, the wider coverage you are. But naturally, there's the case of costs, so you can't just keep on burning up money for all these nice little tools, even though you probably would want to. So you need to think about, for example, in GitHub Advanced Security's case, how big the licensing costs would be depending on the number of your developers in the company. And then, what's the big question? Yeah, what's the point? Microsoft now has 3 products for the same thing. We have GitHub, GitHub Enterprise, and Azure DevOps. Why? And in the future, we are moving to the GitHub and GitHub Enterprise. But at the moment, Azure DevOps still has many, many great features. So there's great project management features, tracing and auditing through work item linking. Then we have more granular permission management, flexible licensing. So for example, if some people just want to read the documentation from the wiki, we can give them a really cheap stakeholder license instead of that always costing $20 per month like for GitHub Enterprise. Then there are more mature pipelines in my opinion at the moment. And then we also have test plans and printable wikis, so when we do the project documentation or wiki, we can easily print a PDF out of it and send it to our customers. So these kind of things are hopefully being developed for GitHub Enterprise, and then we can migrate to that platform. But I don't see that happening immediately, so we are in no rush. The company I work for, we are still using Azure DevOps, so...
Yeah, the user base for Azure DevOps is enormous when you compare it to GitHub Enterprise.
I basically talked about this already. So yeah, that's it. And we have 1 minute left.
But you rushed it a bit in the end, but okay, we made it, okay.
We need to talk about this, you're talking too much. Okay, any questions?
Yes.
In the past 2 days I heard about SendGrab and also SonarQube.
SonarQube is the on-premises version of SonarCloud. So SonarCloud is the cloud version. If you want to use SonarQube, you need to set it up on a server yourself.
Okay, I see. So you said that's also a good alternative to DevOps?
Yeah, I love Sonar Cloud personally.
Okay, and how about the privacy aspect of all those, like GitHub, Azure DevOps, and Sonar Cloud?
Well, when you're using Sonar Cloud, they will of course get access to your data, so you need to kind of trust them. And if you're using GitHub or Azure DevOps, then Microsoft has access to your data, but then again, the code is already there. So that would be like the more secure option to use the Microsoft tools instead of the third-party tool.
Okay, thanks.
Any other questions? Yes?
How is your experience with alerts when using the GitHub security features? Is it overwhelming?
Well, it depends, but as a as a consultant's answer, I know, but it really depends on well, how much code you have, what you activate, on which repos, how much activity there is.
Is there a way to tune it?
There is a way to tune it, so the configuration options sometimes offer the capability to reduce the amount, change the, what was it again, like in Sonar Cloud, the quality gates, so you can say, okay, only alert me when this or that vulnerability, or when this vulnerability with this status emerges. That is possible, but it is limited, the configuration options, that I must tell you, yeah.
Okay, and the last question.
Is it possible to run the code QL scans in separate external pipelines, like in an on-premise TeamCity installation?
Yeah, there is a CodeQL CLI that you might use that can be integrated, like, well, any command line tool integrated into something else. If you're using something else, then you can use that, and then you can send those, well, the results, let's say, you can send those to GitHub if you want. Yeah, that should be possible. It's also quite nicely detailed in the GitHub documentation how to do that. There are, of course, a few prerequisites, but yeah, it should work.
All right. We're done here, I guess 2 minutes over time now. Thank you very much. I hope you had a great conference, and if you have any more questions, you can find both of us on social media by our names. So I'm Laura Kokkarinen, he's Thomas Vochten. So
Thank you for being here.
thanks.
Thank you. Don't forget to rate.